Great. So question 8. A curve has equation y equals 2x squared. Points A and B lie on the curve with coordinates 5 and 5 plus h respectively. Show that the gradient of the line AB is 20 plus 2h. It's not differentiation, it's just the gradient of the line between 2 points. We've got a curve, we've got a point on it with coordinates 5 and, well, what would the y coordinate be there? 2 times 5 squared, 5 squared is 25, so that's 50 as the y coordinate. And we've got another point up here, the point B, that has x coordinate 5 plus h and y coordinate twice 5 plus h squared, because y is 2x squared. There we go. Part 1 of the question is simply saying, find the gradient of that chord, gradient of that straight line joining those points. And we know how to do the gradient of the straight line. The gradient AB is, well, even if we haven't remembered that formula, y2 minus y1 over x2 minus x1, it's the change in the y values 2 brackets 5 plus h squared. I've put the squared in one place. Take away 50 divided by 5 plus h, take away 5. If we simplify that, look at what we've got 2 lots of 25 plus 10h plus h squared, take away 50 over h, because 5 plus h minus 5 leaves us with just h. So this is 50 plus 20h plus 2h squared minus 50 divided by h. Or very conveniently within that, the 50 would subtract itself away. We're left with 20h plus 2h squared over h, and I'm giving kind of maybe more detail than you'd need here. If we factorise that, you've got h brackets 20 plus 2h over h. H is a common factor of the top and bottom, so cancels out at that stage, leaving us with 20 plus 2h, or 2h plus 20, as the gradient was supposed to be. In fact, it was 20 plus 2h, wasn't it? So I'll leave it as I've done it that way around. So I'll leave it that way around. There we go, Colin dancing upstairs. For 3 marks, and that was relatively straightforward, wasn't it? It was just a case of working out the gradient of the chord. You can find gradients of straight lines. Then it said, explain how the answer to part 1 relates to the gradient of the curve at A. And there were quite a few of you just having a go at making something up. What does this mean? This is how we came into differentiation. And it says that as these 2 points get close together, this chord would converge, the value of the gradient of that chord would converge on the value of the gradient of the tangent. The limit, as h approaches 0, the gradient of the chord is the gradient of the tangent. So we need to express that in some way. They were looking for something along the lines of, as h tends to 0, then think about what that means. If h is approaching 0, as these 2 points get close together, then the gradient would tend towards 20. The gradient of A approaches 20. The example that they gave was as h tends to 0, the gradient will be 20. It's just an indication that you are understanding the idea that it's a limit, that as these 2 things get closer, it gives you that value. But you really needed to refer to 20 in there somewhere as being your answer, and talk about h approaching 0, as you did it. Then it says the normal to the curve at A meets the y-axis at point C. Find the y-coordinates of C. Normal to the curve at A meets the y-axis at the point at C. Well, in that case, if we're going to do this, we need to now know that at A, the gradient is 20. We need to have established that fact. Without that fact, we're going to be a bit stuck with part 3. So at A, the gradient is 20. The gradient of the normal must therefore be the negative reciprocal. So minus 1 over 20. We've already established that A is the point with coordinates 5, 50. That's what we said, wasn't it? So the normal at A is y minus y1 is m x minus x1. That's the normal at A. And we need to know where it meets the y-axis. The normal to the curve meets the y-axis at the point C. That's when x would be 0. You could just rearrange that. I'm going to rearrange the equation. It's that, isn't it? So y is minus a 20th of x, quarter plus 50, 50 and a quarter. I don't really like giving it a mixed number, but there you go. There's our y-intercept once we've rearranged it. So therefore, C is the point, 0, 50 and a quarter, or 204 over 4. That would be right, wouldn't it? 201 over 4, sorry, not 201. There you are. You needed to give 50 and a quarter as your final bit. Final y coordinate. See there it is. Okay. You were a little bit stumped in that question because if you hadn't identified that the gradient at A would be 20, based on what you've done earlier, then you weren't going to get that equation that wasn't going to work out. But it didn't depend on what you did in part 1 because it's there, isn't it? There's show that the gradient is 20 plus 2h. You knew it was to do with 20 plus 2h at that point already. Now it was given. Okay? There we go, and that's chords and stuff.